Good afternoon.
Good afternoon.
So, any questions? Yeah, so today we have our lab, and I'm sure you already have the lab syllabus for this inter semester. And so this today will be our first lab. We will do the measurements, and let me share my screen. Can anybody get access to this website? Like you can get access to all our lab menus.
Yes.
Like the syllabus. Great. Let me see. Browses in the waiting room. Okay. Just give them 1 more minute. We will start at 2:05. And you can start like you can start click this one because this class is Physics 207. We will do measurements today. And so today we have 4 labs in total. So in this lab we mainly focus on like how do you measure things and how like every time like even you and your partner measuring the same thing, maybe you have a different result. That means like the error always exists. And how do we so what should we treat with the errors? Is it inevitable, or like we can just minimize it to the smallest, like to reduce its impact to our whole measurements. And also we will cover how we gonna convert the units from like we know centimeters to meters to kilometers. And also I know like we use inches a lot and feet a lot. So we when we do the measurements, we prefer to use the the unit that is meters or centimeters. Okay, we have 27 students here. Okay, so so today you may need a ruler and stopwatch. You can also use your phone. Like it has a stopwatch function, and we later on we will measure the coin, the book, or a rim of paper, also your thumb. If somebody already read this and prepare for the lab report for the introduction and the procedures, you're probably already familiar what we're gonna go through today. So just like a very quick review about the introduction. Um, so any physical science requires measurements, and the lab involves making several measurements of some fundamental units of measures, a length and a time. So like in physics, we often use functional relationships to understand how one quantity varies as a function of another. So we have a linear relationships, and we have also other types of relationships. And so this is just to give you example, and just to get you familiar. So when we do the measurements, we can plot a graph that represents its relationship. And the first experiment is to measure your heartbeat. So when you try to sense your pulse, and then you measure how many seconds it passed for each heartbeat. And you measure 3 times and take an average, and you write this in your report. This is for the first time measurements. So you will get a sense how, we know we have heartbeat every day, and we don't have a sense of time. How long does it takes to have another heartbeat? So they just make you understand, get familiar with the time, you know how fast the time passed. And the second second experiment is to measure pi. So we here, we can use Google Maps to find the 3 circular features, and each have a different diameter. And then you measure the diameter, and you measure the circumference, and then you know the C equal to pi d. So then you know how to calculate the pi. So here you measure the circumference and the diameter of each one using the map interface. And here's how. This one, if you click, it will teach you how to do the measurements. But I will also give you an example. So in your lab report, indicate which features you are recorded in the information and place your measurements of your circumference and diameter in table 1 below. So what does this mean is you pick a few examples, and you measure the diameter and measure the circumference, and you tell me what's the object name, and then what's their diameter. Remember, there's the meters, and their circumference also in unit of meter. So then plot a graph with circumference on the y-axis and diameter on the x-axis. Determine the slope of this graph. So anybody tell me what is the slope here means? Any volunteer? Okay, I'll just pick someone. Arthur?
You said what's the slope, right?
Sorry?
The slope?
Yes.
For which part of this? I guess it's sort of shows the trend, pretty much.
I mean, you know what is the y-axis here?
The x-axis and the y-axis. Let me see. The diameter and circumference. I think diameter would be the x-axis, and the circumference would be the y-axis, and it would be a exponential kind of thing, because pi r squared and stuff. Oh no, this is
pi square. Remember we were doing the circumference.
Yeah.
It's So do you remember the equation for calculating circumference? Okay, you can search.
Okay, it'd be 2 pi r. So, but r is radius. So since it's diameter, it'd be diameter divided by 2. So it'd be diameter divided by 2 pi. It'd just be 2 pi. Yeah. It'd just be pi diameter, I think.
Yeah, pi diameter. Pi times the diameter is the circumference. So when you plot the y-axis as circumference and the x is diameter, what's the slope would be?
It'd be like it'd be upwards, yeah. Yeah. Oh, you mean like the?
Yeah,
Okay, so this is-
what does this mean? Like, okay, maybe I.
visualize it.
Yeah, it's supposed to be. Sorry, I just like get my iPad so I can draw something.
Okay. Okay.
So here I can tell you the slope is pi, because
Yeah.
yeah, right.
Yeah. It's just like upwards. It's just like yeah.
Yeah. So wait a minute. Okay. Okay. So because we know the equation C equal to pi d, like a d equal to 2r. So here, how do I make it like simple?
Okay.
Hold on. So we know C equal to 2 pi and r. Here r is radius.
Yeah, but you know, yeah, diameter divided by 2 is equals to r.
Yeah, and the d diameter equal to 2r. 2r. So the equation will be C equal to pi d, right? So if you plot, so it's like a linear, and
Yeah. Yeah, it'll just be linear.
right. So like if you plot y as circumference, and the x-axis will be the diameter, then the slope will be the pi. So here, you can measure, you determine the slope of the graph. That means you have to determine the pi value.
Yeah.
So you would, yeah, thank you, Arthur.
Okay.
So like here, you will choose three, find three circular features, and list here. Like you can measure anything, like that is bigger, or like you can see, you can at least you can observe in the Google Map, because it has to be big enough. Okay, Hassan.
Yes, so I have a question. So how are we going to like measure it in the map? So is there like a tool in Google Maps that will allow us to do that?
Yes, good question. I'll show you just in a minute.
Oh, okay.
Sir,
Okay.
I have a question.
Yes, please.
Yeah, when I download the PDF, how can I write in it?
PDF.
Are you able to write on your PDF?
You are not able to. You can just make your own. So this one.
I can make. Do I have to write everything, or I can just make my own tables?
You can make your own table, and also you just simplify. So the lab report, because last time we didn't go over the requirements for lab report. I just want to go over this lab first, and then we will go over the lab report, the requirements. So I'll tell you how you do and how you put the table in. Yeah. So here you can just like you cannot write here anything.
Yeah.
Yeah.
In today's recitation, are we actually gonna do it? Or you're just gonna explain to us and then end the call?
Yes, you're gonna do it, because today is our lab, and
Yeah,
the
but
next week
we're
is
gonna do
our
it
research.
in class, right? Right now.
Huh?
Are we gonna do some of it in class?
Yes.
Okay. Thank you.
I mean, I explain at the beginning, and then you will do your experiment. And if you have any questions, because I'm here, and you can always ask me. Or yeah. So here, yeah, you have to paste. I mean, you have to create your new one, your own table. And so you go to Google Maps, And so if you don't know what you want to measure, you don't know any like bigger stuff, here are some examples you can just look up. And let me say hint two, you really meteor strikes the Earth, leaves a larger crater behind it. That's a general circular. Can you find any of those? Okay, so here are some examples. I don't think, so they basically give you 3 hints. I can try to help you to find the circular objects so you can measure. Let's just take one of the examples. Open in the new lab. Okay, so we're gonna measure this one. It's close to circular, but there's some very like not a perfect circle. So, oops. Can anybody see my screen?
Yes.
Okay, so you right click and then measure distance. You click this one, and okay, so here is the start to measure. So you can draw here. I mean, you click different you click different area, then it just automatically like draw lines to connect those 2 dots. And then just do. If you're free, then you can just like do while you're listening. So you can get a little bit of sense how we measure. Okay, so it's close.
How'd you get those lines again? Sorry, I didn't see that part.
Right click, then there's a measure distance on the bottom of the menu.
Thank you.
So here, total is 4 miles. Wait. Here is 4 miles, right? Oh my God, I think here. Okay, this is 5, 6, 4. Okay, if I make it close to the original point, it's 5.57 miles. It's close. So the circumference is 5.57 miles. Anybody have questions here? Okay, so if no, then we measure diameter then. So let me see, diameter. Maybe just from here to, okay, okay, so here's a radius. And maybe, okay, let me see, is this in the middle? Oh, okay, sorry, I should get a new point because otherwise it would mess up. Let me see how to remove. Okay, if you want to remove something, you want to delete, if you make a wrong measurement, you just click. Let's see here. Okay, so this is 5, so the circumference is 5.57 miles. And we want to measure diameter. Wait, I have to get rid of this, I think. Let's reopen a new window. So if we want to measure the diameter, then we can start from here. Oh wait. Okay, measure distance and get 1 here and here. So the diameter is 1.8 miles. So you can do if you want to calculate pi, then you use the circumference to divide it by the diameter. So that's the pi. And you measure 3 times to get an average value. And at the same time, you measure 3 objects. So in total, you will have to measure 9 times for this experiment. Any questions?
Yes. So each time we're picking a different diameter, kind of like different position.
Yes, you can just like, you know why I want to ask you to measure 3 times? Because I want you get a like average value of the diameter. So this time you can measure this one, 1.8 miles. And you can also measure, okay, let's delete this one. Distance, clear measurements. Okay, I measure distance. So I can start from here and do another diameter measurements. So it's 1.77 miles. So you take an average of these 3 measurements, so you get an average diameter, and you measure 3 times for the circumference, and then you get an average of circumference, and then you use these 2 average values to do the math, and you can get the pi value.
Quick question. So are we going to show all of the 3 measurements, or do we just show the average?
You will, so this is for the lab report. So my requirement is you list all your 3 measurements. Like before you put on, like you put the diameter here, the diameter and the circumference are the average. So before this table, you tell me that object 1, what are your 3 measurements values are. Does it make sense?
Okay, so one table that's gonna show all the 3 different measurements of the same object, and the final table will show the average, just average.
Yes. So the first, you can make a early table. Then you take you say, let's say object 1 is a crater in Quebec. And then you measure 3 times diameters, and then it's 3 times circumference, and then another one is average. Or you can.
Professor, I have a
Yep.
question.
Yes.
Do we need to find 3 places or just 1?
3 objects. So in total, you have to measure 9 times.
Okay, thank you.
But do we show those 9 measurements in our table or only one of them?
You do all of them. You don't. I mean, here for the final one, you just give me the average. Let's say we measure this crater here. Say, crater. Okay. I mean, you have another table, or you don't have to make a table. Just tell me your 3 measurements. What are the 3 measurements, and how you get the average value? So basically, you take average of these 3 values, and then you get a average value, and you put this in the final table. So you don't have to be, but you don't have to make another table to show your average measurements, but you do have to show me this table for your average values.
And then we have to create a graph, right?
Yeah, then you create a graph.
So the graph would include all 3 measurements or just that one?
Yeah, I think you better, let me finish here. This one you use 3 measurements for each one to create the graph, because you have 3 points, right? So then you can determine the pi value, but it's supposed to be the same pi value as you take the average. Does it make sense?
So in the graph, say we measured the crater, the storage tanks, and the painted circles at New York Airport.
Okay.
Say you found the average diameter and circumference of those 3. So you only plot 3 points, the diameter and circumference of one of each.
No. I think okay. So you plot because every time you so here so because you measure different objects. So here you plot one graph with its 3 measure points, and this one you plot a graph with 3 measured points, and this one is another plot. Like you basically give me 3 plots. Each plot has 3 points because you measure 3 times, and you have those like values and to try to measure the pi, the slope. Anika?
Do we do the same for the diameter? Sorry, not a diameter, the circumference.
Yes, because each data set, here we mentioned each data set has a diameter and a circumference. If we only measure circumference or only measure diameter, then we only have 1 point. But a data set has 2 points. Like it has a y-axis and the x-axis, right?
Okay.
Any more questions here? So just in short, you plot 3 graphs here. One, for example, one is a crater, one is a storage tank, another is painted circle. And then, so like each one of them, you measure 3 times for a diameter and a circumference. So you have 3 points, and you plot these 3 points in a graph. So you get a graph, and then you take average to the diameter and the circumference. You take those 3 diameters into average, and then you put the number here, and the average of circumference number here. So this is done. You are done with 1 measurement here, and you still have 2 more. Any questions? So if you don't have any questions,
Oh yeah, I have a question. At the end, when it says to plot the graph and then determine its slope, like, do we actually need to like write that down and show it, or is it just something like for us to do for ourselves, like to understand better?
Yeah, you just like the lab report. The purpose of writing a lab report is to basically tell me you understand what you are doing.
So like on the lab report, we would have to like actually draw the graph and like plot everything.
Yes, you have to. You show me there.
Okay.
As like points there.
Okay, yeah,
I
I
will give,
understand.
based on your plot, I will give you your grade.
All right.
Okay. So there are a couple examples you can just look into. And another question is to measure the pi, which is the slope. Because here what we saw is you have the average diameter, average circumference, and you just calculate the pi based on the average values. So that's what I want to tell you. And also, of course, there will be uncertainties in your measurements. Let's say we know the accepted value of pi is 3.14159 and whatsoever. But your measurement, it could be like maybe 3.2 or maybe 2.9. It happens from like from previous students. It is fine because you have an error. But the error is inevitable, so it always comes with your measurements. I don't want to read it here one by one, but just want to convey the information that there is the errors. Let's say, for example, we want to measure the length of this pencil. So you see here, the tip of the pencil is falls into between 9 and 9.5. Sorry, is that mine? Sorry, I'm so sorry. So like there is only one thing we are very sure about is if the length of the pencil is smaller than 9.5 and is bigger than 9 centimeters, I assume. But we don't know. Then if I ask you, give me an answer for the pencil. Okay, everybody has a different answer. There could be 9.1, 9.2. We don't know because everybody say it has everybody has a preference. So so that's why I want to tell you there's Where is it? So the uncertainty, we introduce the uncertainty in the measurement. Which the uncertainty. So whenever you do a measurement, you can only tell me how confident you are. Let's say you tell me it's if you tell me this pencil, the length of this pencil is smaller than 9.5, you have 100% confidence. But you tell me if the pencil is 9.1, so you're not very sure, right? You're not like 100%. It's definitely a 9.1. You cannot tell that. So the uncertainty here, normally we will add the uncertainty range. So basically, let's say this pencil is 9.1 centimeter, and you add uncertainty by plus and minus and uncertainty. Uncertainty is the half of the smallest space. So here, the uncertainty, what is the uncertainty here? Anybody tell me? So let's ask somebody. Sorry?
Said 9.25.
I mean, the uncertainty, first you find the smallest space. Space is 9 to 9.5, so the space is 0.5, right? And half of the smallest space is 0.25, right? Hassan?
Oh yeah, you just mentioned it. I was gonna say plus or minus 0.25.
Yes, that's correct. So basically, because here they measure 9.25, I don't think it's fall into 9.25. Because if 9.25, it would be in between. But here I would say it's 9.1 plus or minus 0.25 centimeters. That is your correct answer. Because you gave the range. You know what I mean?
Yep, that makes sense.
Okay. So the third lab today is to measure some objects in your life. You can measure the diameter of the coin, the width of one of your thumbs, and the length of book, the rim of the paper, or the height of the book, and the width of the book, and the length of a pen. So it's very like you measure your daily objects you can touch, like you're familiar, the objects you're familiar with. And then the purpose here is you have to be mindful that you convert to millimeters, to centimeter, to meter, kilometer. And also when you do the measurements, you tell me the error in the ruler. So the error in the ruler is your uncertainty. Uncertainty when you do like a ruler, let's say you use a very big ruler. So you find the smallest space and take in divided by half, by 2. And take the half will be the uncertainty, which is the error here. And also because you're gonna make this table yourself, and I would suggest you put a unit here. Let's say you see here, millimeter, centimeter, meter, kilometer, they all have a unit, but here it doesn't have a unit. Just put a unit here. So I will know, okay, what's your, what's a unit? Because if you just tell me a number, I don't know what does this mean. It doesn't have any meaning, right? So it's basically a practice. You can do it.
Quick question. So I have to have a ruler that has all this stuff, right? Like a millimeter, centimeter, and meter.
No. Let's say you have a like normally we have a ruler with centimeter. Maybe it's 20 centimeters. I think 20 centimeters is enough. So you can measure the coin, and if you do a 20 meters ruler, and you let's say the coin is maybe 1 centimeter, and then you will convert to it's 1,000 millimeter, right? And it's 0.001. Sabiha.
Yeah, Professor. I was just for the error in ruler, Do we like put any of the unit? Like, can we put centimeter if
Yeah.
it's okay? Or
I mean,
okay.
yeah. I mean, you can use any ruler to measure. I mean, like if you like say, you can basically use any ruler to measure. Um, like here is like you use one ruler, measure all of them, and you got a set of that. Like you got all the data here. Let's say you measure always centimeters. You all got all this column, and you try to convert to millimeter, and convert to the meters and the kilometers. You don't have to measure with a millimeter ruler, centimeter ruler, meter ruler. No, you don't have to do that. You just use one ruler to measure all of them. Peter, please.
The error in the ruler, would it be say for the example when they measure the pencil, would the error be 0.25?
Yeah, if your ruler is like beers, let's say the smallest is 0.5 centimeter, then you can. But as far as I know, for some rulers, you have a smallest is 0.1 centimeter.
I know. I'm saying for that example, the error would be 0.25.
Right.
And do we have and in that box we just put 0.25, no units. In any of the boxes we don't put units because it's on the top, right? It already says
No,
centimeter.
you have to put a unit because I don't know. Like everybody are using different ruler. You have to tell me your ruler list. Like I can know, and also this is a checkpoint. I could know like if you
Oh,
tell
I
me,
see. I see.
yeah.
Yeah,
So
but in the other boxes, do I have to put units because it already says kilometer,
you don't
meter,
have to, you don't
centimeter?
have to.
Okay,
Yeah,
thanks.
if they have a like a unit here, you don't have to tell me because like it's already assumed you know this the units. Okay.
Do we just like when it says error and ruler at the end, do we just put the error for like in terms of centimeter, or do you have to do it for like each unit?
No, you just do one unit. One unit
Okay.
is, yeah. But you have to tell me the unit. Either you put it
Okay.
here, like if you say like it's the error is in centimeter, you put it here, centimeter.
We just have to. Okay.
Yeah, you don't have to write the units here. If
Alright.
you're, yeah, so you can also write the units in each the boxes. So this is like a checkpoint. I will check if you have a unit. If you don't have a unit, I will deduct some point. But yeah, just a
Alright.
reminder. Any more questions here? Okay, last one. Measure, I think that's your last one. Yes. Measure your walking steps. So basically, so you can measure your how big is your step. So you can measure. So you can use a piece of tape, the edge of a tail or shoe, book, or other item to mark a starting point on the floor. Walk 3 normal pieces forward from your starting point. So you basically set a starting point and you walk 3 steps and place an object to mark its endpoint. Then you stop after you walk 3 steps and make an object to mark the endpoint. Then you use the meters or the rulers to measure how far you have walked. And then, so you measure distance between start and end point. You divided this distance by 3 to get an average step. And you record the data in table 3. And so alternatively, you can measure 1 step as shown in figure 3. Okay, so you can also measure 1 step. You just walk 1 step and stop there and measure from the heel to heel or toe to toe. Like don't measure your steps from heel to toe because that's not a step. That's more than a step. Or the toe to heel is smaller than a step. So where you measure and you measure end. So you just like the same start, same end. So this is for the measurement for your steps. Then so you you write down all your measurements, the distance covered with 3 steps, a centimeter, and also you do the unit conversion. and with one step. So basically this one divided by 3, you will have a 1 step, right? And generally boys has bigger steps than girls. You just measure your own. So I will grade them like accordingly. And here are a few questions. Let me see. Okay. So on average, how many steps do you walk to take do you need to take to walk 1 kilometers? So basically, let's say your step is for boys. Let's say your 1 step is 1 meter. So if your 1 step is 1 meter, how far? How many steps do you have to take to walk 1 kilometer? And anyone know the answer? Let's assume someone
1,000 steps.
Yes, correct. So we will take 1,000 steps to walk 1 kilometer, assuming your step is 1 meter. And use your stopwatch to time yourself walking 10 steps, time for 10 steps. So basically, you just time yourself for 10 steps, and write down the time. Determine how long it takes you to walk 1 step. So let's say here, let's say you maybe walk 10 seconds for 10 steps. Okay, let's not make it so, okay, let's say you walk 10 steps within 15 seconds. So how long does it take to walk 1 step? Anybody?
1.5 seconds.
Right, correct. So you basically use the time divided by your step numbers. You get the time for each step. Okay, next one. What is your average rate of walking in centimeter, meter, or kilometer per hour? So basically, you convert your like it's like a math problem. Let's say you using when each step is 1.5 seconds, and you already know how big your step is. Let's say 1 meter, and each step is 1 meter, and time for 1 step is 1.5. You know the speed for your step. So the distance for each step is 1 meter, and the time is 1.5 seconds. You know how to calculate the speed of your walking. Anybody?
100 centimeters per second.
100 centimeters per second. 1 point. Okay, let me think. So
Wait,
one,
no. It was not 1.5. I was thinking of 1.
Yeah, I know. Like, yeah, here is a tricky because maybe you need your calculators to calculate. So, like, basically, the 1 step is 1 meter, and the time for 1 step is 1.5 seconds. So 1 meter divided by 1.5 is meter per second. Is you get a unit of this, and you just convert to centimeters and convert to kilometer per hour. But the math here is Peter.
Yeah, for it says distance covered with 3 steps. When we put down the first foot and then when we put down the third foot, do we measure from the heel to the toe or from toe to toe for that one?
So heel to heel.
Okay.
So always do that.
Okay.
Yeah. So here, yeah, I just try. So how to measure the speed? You use the distance. Distance is your footstep, and your time. And the distance divided by time is your speed, right? The time here also calculated here. So basically, you already have all the answers for this question, and you just do the math. Record all your data for submission in your lab report. Yeah, that's all for today's lab measurements. Let me see. I need to tell you the lab report. Just give me 4 minutes. So So basically, you tell me the lab report format introduction. You tell me what's the purpose of this lab, why you want to do that, what you can, so like why it helps you to basically tell other people you understand on why you're doing this, why you're doing this lab. And also you tell me what you know about the physics behind this experiment. And the lab procedures, like basically tell me how you do your measurements. Let's say if I give your report to somebody who never done this lab before, he could follow your procedures, get the same results as you do. So that's the purpose for the writing lab procedures. So basically tell people how you do so people can follow you. They can follow your thoughts and follow like how you did your measurements. And if you want to make it clear, you can also provide the pictures. And yeah, so so the purpose why you're writing these procedures, I'll give you an example. Imagine you're an engineer and you need to develop your machine manual for people to know how to use this, how to use your machine. It's basically the same purpose for writing this lab procedures and also as well as the lab report. And okay, so 1, 2, 3, 4. We have 4 sections in the lab report. Lab results show your table or graphs. So in this, for this time, you both have tables and graphs, and show your answers to the question. So we basically already covered all the questions. You just like tell me, and when you try to answer your questions, don't just give me a number. And because I'm not, so you like write you. I think I expect you to write the question first. Let's say this one, last one. So 10 time for 10 steps. You just tell me, you copy this sentence and tell me the answer. Don't tell me just one number because I don't know what question you are answering. Does it make sense? For the small questions, you just write the answer and answer yourself below. Don't just give me an answer. Does it make sense?
Yes, Professor. I just have one question though. Do you want us to split these up? Like, do you want us to annotate which is for part 1, part 2, part 3, part 4, like for the procedure? Because it's obviously different.
Oh no, you just write it in one. You just say so like let's say here the introduction. You can be you get familiar with measurements and have a sense of the unit, like what the unit means to you. Like you have a book, but you don't know. Oh, it's 20 centimeters long, and you just get a sense about the objects around you, and also you practice the measurements for calculating pi values by using circumference divided by the diameter. And also you what else, like the unit conversion. So basically everything you learned here, you just can put in the introduction. So like you just basically tell people, hey, I learned so much, and this is what I did for this lab. So basically the introduction, tell people what you do, what you cover. And so yeah, that's for the introduction is for all the 4 labs for measurements we had in this lab menu. Peter.
Where can I find this outline? I'm on Blackboard and I can't really find it.
I sent an email, like I send you email and attach to this one. You mean this Word document?
All I see is syllabus and find virtual experiments here.
I mean, can you like search physics CD, physics 207 CD4 and use the latest one, because the previous one, like we already discard previous one. So anybody else get access to this Word document? Nobody?
Oh, I have it. Yes.
Yeah, so I remember I attached to the document. I attached to the email.
Yeah, there's a link in that first email you can download it from.
Yeah. Okay. So anybody has the same question? They
If
don't.
someone has it, can they just put in the chat if they can? Like just copy the link to the chat.
You mean this Word document?
Yeah.
I don't think I have a link for this.
Is it fine if we use the lab report rubric on like the physics lecture? There's a lab report rubric and other new content on Blackboard, and it provides like a rubric on what to do as well.
So you mean my announcement was there as well?
No, it's not your announcement. It's the one on it's on the physics lecture page on Blackboard, like that section. Like if you go to other new content for like the physics lecture, you can see like a lab report rubric.
Yes. You can refer to that, but I think everyone has every teaching assistant has their own rules for. But you can refer to them, like get a better sense. But all my requirements here, you can. This is a must-have in this requirements, and you can add more, like, or you can look up other rubrics to make it more readable, more understandable for others. But here the requirements I have, let's say for your the graphs, the tables, and the question, you have to when you answer your questions, you have to list your question before you answer it. So this those are the must have. Yeah. Anybody has any questions?
Yeah, just to clarify, for the lab procedure, right? We should have 4 different lab procedures for each measurement.
Yes.
And the same for the introduction, or the introduction can be one thing?
Yeah.
Okay.
Professor, I'm not sure if you said that, but for the first part of the lab, do you have to have a table?
First part of the lab? Let me see. You just first part. You don't have a table. You don't need it. You just tell me how many seconds pass between each heartbeat. You measure 3 times, right? I said you just take an average of your 3 measurements.
And we just write it down on the third portion of the lab report, right?
Yeah. Just 3.
Okay, thank you.
3 times, like maybe 1 second, 1.1 second, 1.2 second, average 1.1. Just tell me that. I
Okay,
mean,
thank you so much.
Sorry. Okay, so for part 1, you don't have much thing. You don't have to write much about your procedure. You just measure then what you can tell, but it's just up to you. Like some procedures can be very need more details, but this one you can just tell me. So okay, you just say use a stopwatch to measure the time between my heartbeats. That's the procedures. You don't have to be like very long. So it just to make sure other people can understand how you do conduct your measurements. And for this one, you don't have to tell me like how you measure 3 objects. You measure, like you just tell me, I found this crater, and then I in Google, I right click to find the measure distance menu, and click draw the circle and the diameter, and then divide it by and measure 3 times. You can just tell me one you can just tell me one. So like for example, in this case, even you measure 3 times, and you measure actually in total 9 times, but you just tell me procedures for 1, so I know what you do. You don't have to repeat yourself, because like people will understand you. You just want to make sure you know what you're doing. That's my purpose.
Also, another question for part 2. Do we say the slope for 3 graphs or just one place would be fine?
3 graphs or
just like one of them would be fine. The slope.
3 of them. So each of them, like you measure 3 objects. Each object has a graph.
Thank you.
All right, we're okay. Answer. You go back to this question. It will make sense to you. Yes. So I still want to address that. You have to like list your question before you answer it. And the conclusion part will be, tell me what you learned from this experiment. You learn anything new? It can be like an open-end question. It can be anything. And yeah, what do you think you're doing your experiment? Are you satisfied with yourself? It's just like a very you kind of try to tell me what you think about this experiment. Or you think it's too easy or it's a little bit hard? Yeah, just tell me your opinions. And yeah, that's all. So
one more question. For the Google Maps, do we convert the miles into meters?
Yes.
Okay, thank you.
Because we in our lab table, we don't have any for maps. So you can just Google because I'm not very sure. I'm more familiar with the meters. So you just Google the mile conversion to meters or kilometers. Yeah. Any more questions?
Oh, we should for lab part 2, we should draw the graph or we can do it on Excel.
Part 2. Part 2. You mean for the table?
Yeah.
I think even Word you can insert table, right? No? Let me see. Insert table, see here. Let's say I wanna have let me see. 1, 2, 3, 1, 2, 3, 4. 3, 4, right? Table. 3, 4. So I have this table, right? Object. Diameter. Circumference. So 1, 2, 3. Let's see. I prefer you use Word because you're gonna submit your report. You just submit one. That's enough. If you wanna submit Excel, or you can also do in Excel. Then you do a screenshot, paste in your Word. So it just like make one piece. So I can, when I grade, I don't have to open everything, right?
Right.
Yeah. Any questions?
Yeah, I have a question.
Oh, yes.
Yeah, when are we allowed to leave the meeting or we have to stay till 3:30?
No, I need to do like a attendance. So you don't have to be here. Like you can just do yourself. And also we have a recitation next time. Then you can, yeah, PDF and Word both okay. Like anything. I just want to have you have one piece. So don't give me an Excel and a Word PDF. Like, I don't know where to look for your answers. Just make my life easier, make your life easier.
So we have to stay in the meeting, right?
You don't have to. I mean, wait a minute. Now I do attendance check.
Oh, so once you do attendance check, we can press leave meeting or no?
Yeah, you can.
Okay.
Just a second. So next Tuesday we're gonna meet at the same time. If you have more questions, you can feel free to ask me, or yeah, any questions. I prefer you send me your question before so I can have the review before the recitation. So the recitation is also required. You have to be here. If nobody has questions, then we can leave early, but you have to be here. I have to be here as well. So today, wait, today why is supposed to, okay, I think last time I don't need to take attendance. What do you think, what do you guys think of this like lab, this measurement stuff? Do you think it's very hard?
It's pretty easy.
It's pretty easy.
Or just tedious.
Yeah.
Yes. Yeah. So I think maybe next time we don't need to meet. So today I take the attendance for the tutorial for lab 1. Does this sound good to you guys? So you guys next time don't have to come?
Wait, so next week, no recitation?
Yeah. If you have questions, feel free to like ask me.
I see.
What do you guys think? Because like so I will take attendance for today for like on the tutorial I show you. So because
I like that idea.
I think it confused me because last time I took attendance here, and then I'm supposed to take a tutorial 1, and actually we have total 7. So next time actually is our tutorial, and this time should be our lab attendance. So it's a little bit confusing. So I want to take attendance for today, for the tutorial 1. So Peter, you have a question? You just unmute yourself.
No, I don't have a question. Did you take attendance already?
Oh no, I'm taking now.
Oh, okay.
Anika, you have questions because you raised your hand.
Hi. If I have a question, can I email you anytime?
Yes, feel free to email me.
Okay, thank you.
Yeah. So actually last semester, what we did is, wait, did anybody left? Just wait a second. Last semester, we didn't take do much tutorial. I just asked them whenever they have questions, you just schedule a Zoom meeting with me. And when there are more people schedule meeting with me, I just have a tutorial for everybody who could sit in to ask questions. Also considering this lab reporting lab, we don't have much technical issues, like very hard to understand. So I prefer next time we probably, you guys, what do you guys think? You want to meet next time, or you can email me questions.
I think it's just better if we meet in 2 weeks and we just email you questions.
Okay. Yeah.
Wait, but in 2 weeks, is there going to be a lab due on February 22nd or 23rd, whatever it is?
Let me see. The lab report is due next week. Let's see.
And when's the next lab report after that due?
Sorry. So lab report, next lab report is due on Tuesday, February 16th. Wait, is it?
What about the one after that? When's the next one after that due?
So because we have labs every 2 weeks, the next week will be, so February 16th is our tutorial. It's supposed to be our tutorial, like recitation lab. And so we don't have lab. So the following week we don't do anything.
Oh, so labs are due every 2 weeks. So this one's February 16th. The next one is gonna be due after 2 weeks, and then after that 2 weeks to. Okay, I see.
Yes, but it's so yes, like generally you think this way, but actually it's like due the week you did your lab, like you did the experiment, 1 week after you did your experiment, because we do our lab every two weeks, right?
Yeah.
Yeah.
Okay, so did you take attendance yet?
Yeah, I just like so Anika is here. When I say, is Anika here?
Yes.
Ali is here.
Ellie Honing?
Yeah, Ibrahim.
Yeah.
Okay, so when I call your name, please just tell me you're here or yes. Just like we can go a little faster so everybody can leave faster. Like can leave early. Okay. Anika Tyson. Oh, she's not here last time. Bati Yasin. Bati Yasin.
They mentioned in the chat they're here.
I mean, can you tell me something? Because I need to focus on this. You can just tell me. I need yourself, please. Bostrom Alexandra.
I'm here.
Fadia.
Here.
So this is Feng Arthur.
Here. Arthur Fong, yeah.
Feng, okay. Sorry. Okay, so Michael.
Here.
Peter. I know Peter is here.
I'm here.
Mark.
Here.
Ziyan.
Here.
Munino Hassan.
Here.
Jack.
Here.
Ali.
Here.
Joe Xue.
Here.
Zhou Shi Parth.
Yeah.
Meet you, Andy. Andy.
Here.
Mohammed.
Here.
Father.
Here.
Nia Nafil.
Yeah, present.
Okay. Wait, we have 30 students. We have total 29. Okay, I think somebody is not here. Sabiha.
Here. Here.
Okay. Mahmoud Musa.
I'm here.
Anes.
Here.
Sheva.
Here.
Camel. Okay. Bujar.
I'm here.
Windsor.
Here.
Amr.
Here.
Heather. Peter. Talker Hader, no. And then
Here.
Michaela.
Here.
Okay. So next time we don't meet. If you have questions, just email me. Does this sound good to everybody?
Yep.
Okay.
Sure, yeah.
Thank you. Remember, it's due next Tuesday, 4 p.m.
All right.
Okay.
Have a good day.
Thank you. Thank you.
Thank you so much. Have a great week. Bye.
Thank you.
Thanks.
Thank you.
Bye.
Professor, I actually have one last question real quick. I was just looking at for part one. Do you just want us to list the time between heartbeats? Like for how many heartbeats do you want us to do it for? It doesn't seem to give many details.
Yes, so for the first one, you measure like 2 heartbeat between how long it takes between your heartbeat.
So yeah, so you measure the time between heartbeats, but how many how many do you want us to do that for, and like what is there a specific format that you want us to present that information, or just list the time?
It's very easy. Just
list it. Okay. Should we do like 5, 10 heartbeat? I don't know. Is there a specific amount you want?
I mean, you don't have to. You just measure true heartbeat. Okay, let's say true heartbeat. You don't have to like measure.
Okay, I got you.
Yeah.
All right. Thank you very much.
Thank you.
Yeah, just a quick question. Did you mark me present?
Sorry.
Did you mark me present?
Mia.
Yeah.
Sorry, I'm so sure. Yeah, yes, you're here.
Okay. Have a good day.
Thank you. Bye, everybody.